Okay, good morning, my esteemed viewers out there. It's your favorite tutor, the formula. So we are still looking at the relationship between revenue, elasticity, and slope. Now, in my previous video, the one I did a while ago, I told you the relationship between these three things, elasticity, revenue, and slope. I told you the relationship between them verbally. Now, in this class, we are going to look at the mathematical and the graphical aspects of those verbal explanations. Those explanations I made earlier, I just want to put them in a graph and I want to put them in a mathematical form so that it can appeal more to my viewers. Now, we already said before from my explanations in the previous video that whenever total revenue is rising, demand is always elastic and price is always falling. And at that point, marginal revenue is always what? Positive. That whenever demand is unit elastic, total revenue is always maximized and marginal revenue is always what now? Zero. That was what we said when we were looking at the relationship. And we went ahead to say that whenever demand is inelastic, that total revenue is always falling and marginal revenue is always what now? Negative. We have already said all this one. So I want to draw the graph of these things we have said, then we are going to analyze it mathematically. Now, graphically, I want to put it on the graph now. We are going to have something like this. Now, this is the total revenue function. This is quantity consumed. Let this be the point of origin. This is quantity demanded, and this is price here. Now, this is our total revenue curve. This is total revenue curve. Let's call here point A. Let's call here point B. Let's call here point C. So at this point A, it is obvious that total revenue is rising. Hence, elasticity of demand. Hence, elasticity of demand, ED, is greater than 1. And at the same point, MRO is greater than 0. So please, whenever total revenue is rising, as you can see from my board, then it is obvious that marginal revenue will be greater than what? 0. It will be positive. Marginal revenue will be positive. And it is obvious that elasticity of demand is always what? Elastic. That demand is always elastic at that region. Now, those of you that have a very good knowledge of mathematics, you should know that this particular point is called the turning point of a curve. If we were to look at this guy mathematically, the turning point of a curve is that point where the curve is momentarily at rest. So it simply means that anything d something here should be equal to what? 0, which is the turning point of the curve or the stationary point of the curve. At this point, marginal revenue is 0 and total revenue is maximum. Remember, like what I said before, this is the turning point of a curve. At the turning point, we have what is called critical values. Now, the critical values are the values of the turning point of that curve. These critical values can be minimum values, it can be maximum values, it can be point of inflection. It depends on the second derivative test we are carrying out. So, since this is the turning point of this total revenue function, at this particular point, ladies and gentlemen, at this particular point, demand, ED, elasticity of demand is always unitary. And total revenue is always maximized and marginal revenue is always what now? 0. Please take note. Now, this particular point you are seeing, this particular point is, if you can see, total revenue is falling, MRO is less than 0, marginal revenue is negative. We are going to discover that at that same point, demand is what? Inelastic. ED is less than 1. Now, let us see the implications of this thing on this demand curve. Now, let's stretch this demand curve this way. So, this is the demand curve. This is the demand curve. A arrow is equal to P is equal to D. Now, if I take this down and I take this down, remember that provided the market has a downward sloping demand curve, then the marginal revenue curve of the market is a curve that starts from the same vertical axis from the demand curve, and the slope is twice as high as the slope of that demand curve. So ladies and gentlemen, this man you are seeing here is the M arrow curve, the marginal revenue curve. As you can see, at this point where total revenue is maximized, the value of M arrow here is 0, which corroborates my point. Please take notes. So it is obvious that whenever total revenue is rising, as you can see, what can you say about demand? Demand is always falling. So it simply means that if you, as a producer, want to maximize profits, you must always look out for the elasticity of your commodity. If you want to maximize profit and you discover that your commodity has an elastic demand, all you need to do is to reduce your price. Because when you reduce your price now, there is going to be a small fall in your revenue and increase in the revenue. The revenue will fall because consumers now will reduce what they are demanding for. But since what they are buying is lower, since what they are reducing is lower than your increase in price, you are going to gain. The net effect is a gain. So whenever demand is elastic, now what you have to do as a producer to make profit is to reduce price. Provided your price is not lower than your marginal cost, you are going to maximize profit. And when you discover that your commodity is, the demand for your commodity is inelastic, what you are supposed to do as a rational producer is to increase price. Although there will be a reduction in quantity demanded, but since the increase in price is greater now, the net effect is what? Increase in your profits. So this is the graphical illustration of the relationship between what now? Total revenue, elasticity, and what now? The slope of a demand curve. Now, in my next video now, I am going to do the mathematical analysis or whatever you are seeing here. We are just going to go through calculus now to show the relationship that will exist between. Now, it may interest my viewers to know that marginal revenue can be written as price bracket 1 minus 1 over demand, 1 over 1 minus elasticity of demand. So M arrow can be given as P, which is average revenue, bracket 1 minus 1 over elasticity of demand. So how did we arrive at this formula? It is with this formula we can prove everything here. So in my next class, I am going to derive this formula, working through calculus, and I am going to prove all the graphical illustrations you saw here. So please keep a date with me.